Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 6 of International A-Level Edexcel P4 January 2022 paper. So it says that three consecutive terms in a sequence of real numbers are given by k, 1 plus 2k and 3 plus 3k, where k is a constant. Use proof by contradiction to show that this sequence is not a geometric sequence. So as you know that in the technique of proof by contradiction, what we do is we assume that the opposite statement is true. The opposite condition is true. And by a series of logical steps, we prove that our assumption is wrong. Our assumption is false. And so in this way, we would be able to prove that our assumption is wrong and the original condition which is given to us in the question is correct. So in this particular question, we need to show that this sequence is not a geometric sequence. So we will assume the opposite condition of this. We will assume that it is a geometric sequence. So here we assume that this sequence is a geometric sequence. Assume that the sequence is geometric. Okay. And now we will prove that by a series of logical steps that this is not a geometric sequence. Okay, so our assumption is that the sequence is geometric. And as you know that in a geometric sequence, you have a common ratio, and common ratio is basically calculated by this formula term 2 upon term 1, which is exactly equals to term 3 divided by term 2. Okay, so if this is a geometric sequence, so it would definitely satisfy the equation T2 divided by T1 will be equals to T3 over T2. Okay, so term 2 is basically 1 plus 2k divided by term 1, which is k. This will be equals to 3 plus 3k divided by 1 plus 2k. So if this is a geometric sequence, then obviously left-hand side would be equals to right-hand side of this equation. But now we are going to prove that this is not the case. So first of all, I'm going to do the cross multiplication. So 1 plus 2k times 1 plus 2k, this will be 1 plus 2k whole squared, and this is equals to k times 3 plus 3k. Okay, so 1 plus 2k whole square will be expanded. So a square plus 2ab plus b square, and this is equals to 3k plus 3k square. And in place of a, I'm going to write 1, and in place of b, I'm going to write 2k. So now in the next step, I can say that 1 plus 4k plus 4k square is equals to 3k plus 3k square. All right, and then 1 plus 4k minus 3k plus 4k square minus 3k square is equals to 0. So here we have the equation in a simplified form: k square plus k plus 1 is equals to 0. So now what I'm trying to tell you is that if this is a geometric sequence, then k square plus k plus 1 is equals to 0. This would definitely have a solution or solutions. Okay, but since we want to prove that, we want to show that this sequence is not a geometric sequence, this definitely means that k square plus k plus 1 is equals to 0 would have no real solutions. Okay, we need to prove that k square plus k plus 1 cannot be equal to 0. All right, and since the coefficient of k square is greater than 0, this quadratic graph would have a minimum turning point. So we need to show that k square plus k plus 1 is greater than 0 for all values of k. So for that purpose, what I'm going to do is convert this k square plus k plus 1 into a completing square form. So 1 multiplied by k plus 1 over 2 times 1 whole squared plus 4 times 1 minus 1 square divided by 4 times 1. So here I have basically used the completing square formula, and in order to convert a generalized quadratic expression into a completing square form, we use a particular formula. So let's say ax square plus bx plus c. This is basically the generalized quadratic expression. And if you want to convert it into a completing square form, so the formula is a multiplied by x plus b over 2a whole squared plus 4ac minus b square completely over 4a. So I have used this particular formula over here. All right. So we can say that k plus half whole squared plus 4 minus 1 completely over 4. So plus 3 over 4. So I'm going to erase the formula from the top so I can continue the working on the space available on the top. So far, what we know is that when you express k square plus k plus 1 into a completing square form, you get k plus half whole squared plus 3 over 4. So we need to prove that k plus half whole square plus 3 over 4 is always greater than 0 for all the values of k. Okay, so as we know that k plus half whole square is greater than or equals to 0 for all values of k, for all values of k, because when k is equals to minus half, k plus half whole square will be equals to 0, and if k is not equal to minus half, k plus half whole square will always be greater than 0. So if we combine these two conditions, we can say that k plus half whole square is greater than or equal to 0 for all values of k. And since 3 over 4 is always greater than 0, so therefore we can say that k plus half whole square plus 3 over 4 is greater than 0 for all values of k, and therefore we can say that k square plus k plus 1 is greater than 0 for all values of k. So this essentially means that k square plus k plus 1 is equal to 0 cannot be solved, because k square plus k plus 1 is greater than 0 for all the values of k. So this basically contradicts our assumption. Okay, so I'm going to make some space, let's say over here. I'm going to erase this earlier working so that I can mention the final proof in words. Okay, so this contradicts our assumption. This contradicts our assumption that the sequence is geometric, because our assumption was that sequence is geometric, and hence our assumption is false. Our assumption is false. And now we can finally say that, therefore, the sequence is not geometric. The sequence is not geometric. So this is supposed to be our final answer, and in this way we are going to write the proof. So this was the question number 6 of International A-Level Edexcel P4 January 2022 paper.